Welcome everyone to Algebra 1, Section 4.5, Arithmetic and Geometric Sequences. So first we'll talk about arithmetic sequences. And an arithmetic sequence is defined as a sequence in which the difference which we will define as D. So a sequence in which the difference, I'm going to fix my n there really quick. It's not a very good n. I'm going to fix just the latter half of difference. Between any two consecutive terms, consecutive just means in a row, is constant. So essentially it's increasing or decreasing by the same amount between any two consecutive terms, any two terms in a row. Common difference is, once again, that letter D, and it is the numerical difference, which, as we mentioned before, we defined as D, between any two consecutive terms. So we said the arithmetic sequence is a sequence in which there's a constant difference between terms, and the common difference is whatever the difference is between those terms. So we're going to identify whether these are arithmetic sequences or not, and if they are, we're going to identify the common difference, D. So number 1, from 1 to 5, we increase by 4. From 5 to 9, we increase by 4. And from 9 to 13, we increase by 4, and it just keeps going. And so as we can see, it's increasing by the same amount. And so yes, this is an arithmetic sequence. And the D, or difference, is 4, positive 4. It's increasing by 4 from one term to the next. Number 2, from 1 to 3, we increase by 5. From 3 to 5, we increase by 2. We can already tell these are not changing by the same amount. They're not increasing or decreasing by the same amount. And here confirms it, increasing by 3. So no, this is not an arithmetic sequence. Number 3 here, from 8 to 6 we subtract 2, from 6 to 4 we subtract 2, and from 4 to 2 we subtract 2. So yes, this is an arithmetic sequence, and the difference here is negative 2 because they're subtracting 2 every time. Number 4 here, from 5 to 8 we're subtracting 3, or negative 5 to negative 8. Negative 8 to negative 11, we're subtracting 3 again, and between these last two numbers, we also subtract 3. So yes, this is an arithmetic sequence, and it has a D, or common difference, of negative 3. Number 5 here, we add 5, add 10, that's enough to already tell us the answer, add 20, and no, it's not an arithmetic sequence, it's not a common difference every time. Number 6, subtract 1, subtract 1, subtract 1. Yes, this is an arithmetic sequence with the common difference of negative 1. So now we're going to continue arithmetic sequences. So in order to continue this sequence, we're one total already, it is 1. We have to find the common difference and then find the next 3 terms. So here, the common difference between these numbers is that we're adding 4. And so if we continue adding 4, we get 25, 29, 33. And we could keep going if we wanted, but we're only asked to find the next 3. On number 5, we're subtracting 3, subtracting 3, subtracting 3. So we keep subtracting 3, and we get negative 7, negative 10, and negative 13. And number 9 here, we add 6, add 6. Maybe if it chooses to write it, we'll see. And then add 6. And so then the next 3 would be 16, 22, and 28. Now, we have a formula that we can use to find any term, or what we call the nth term. Nth term is any number we want it to be, nth standing for number. And so the formula to find it is, or the formula to find the formula, kind of interesting, but it's always this pattern, a sub n. Okay, so the value of the nth term in this arithmetic sequence is equal to D, the common difference, times the quantity of n minus 1, whatever number term you want, minus 1, plus a sub 1, the first term in the arithmetic sequence, where d is once again defined as the common difference, and a sub 1 is the first term. So anytime you see a sub any number, that's telling you it's that number term, and a sub n is a generic nth term that can be used for any number. So here we're supposed to write the rule for the nth term for each of these following examples, and then find a sub 19, find the value of the 19th term. So on number 7, we need to find our common difference. Well, these are continually increasing by 6, so d is 6. And we also need to know the first term, and the value of the first term is 7. It's the first one we see. And so we plug that into the formula up above, where it's a sub n is equal to d times the quantity of n minus 1 plus a sub 1. So we plug in 6 and 7 into d and a sub 1. And we distribute the 6, because we want to simplify this. 6 times n is 6n, 6 times negative 1 is negative 6, and we add 7 to that. Now we can combine the negative 6 and 7 because they're like terms, neither of them have variables, and we get a sub n equals 6n plus 1. And that is our formula to find the nth term. So whatever term we want to find, we plug that number in for n, multiply it by 6, add by 1, and we find the value of that term. So I'm going to go ahead and box this and say, hey, that's my answer for the formula, the rule for the nth term. And now we're going to find a sub 19. So in order to find a sub 19, we plug 19 in for n. So that's 6 times 19 plus 1. And if we take 6 times 19 and add 1 to that, we end up getting a sub 19, or the value of the 19th term in the sequence, to equal 115. Number 11, our common difference here, is negative 4, and our a sub 1, our first term, is 30. So plugging this into the formula, we have a sub n equals negative 4 times the quantity of n minus 1 plus 30, the value of the first term. If I distribute the negative 4, I get a sub n equals negative 4n plus 4 plus 30. Combining like terms on the right-hand side, a sub n equals negative 4n plus 34. So that's my rule for the nth term. And now I go ahead and apply this using the 19th term. So a sub 19 is equal to negative 4 times 19 plus 34. And so then we end up having this all equal negative 42. Moving on here, some more examples. 12, the common difference here is 3, whereas the a sub 1 is negative 11. So plugging these into the formula, a sub n equals the d minus, or times the quantity of n minus 1 plus a sub 1. We then distribute the 3, 3n minus 3 plus negative 11. Notice I left the left side blank here, just like with when we were doing functions like f of whatever. If we're doing the same thing on the left-hand side in a vertical alignment, they're all aligned vertically here, then we can just omit the left side in the middle terms, in the middle steps. But for your first and your last step, which we'll see here, we want to write it. That's an option you have available to you. Or you can write it and it's fine either way. And we get 3n minus 14 as our rule. Now we use that rule, and we end up having a sub 19 equals 3 times 19 minus 14. And this ends up equaling, we're giving us the 19th term to be 43. On to number 13 here. Our common difference this time is 2, and our first term is negative 2. Plugging these in, we end up getting a sub n is equal to 2 times the quantity of n minus 1 plus a negative 2. Distributing this 2 gives me a sub n equals 2n minus 2 plus a negative 2. Combining those negative 2's gives me a sub n equals 2n minus 4 as my rule. I then apply that rule by plugging in the 19th term, and a sub 19 is equal to 2 times 19 minus 4. And a sub 19 is 38 minus 4, which is 34. So if you want, you can show the step in the middle like I did, or like I've been doing before, you can just go to the answer. Either way. Number 14, here our common difference is negative 5, and our first term is negative 16. So plugging these into the rule, we end up getting a sub n equals negative 5 times the quantities of n minus 1, quantity, not quantities, sorry, plus a negative 16 or minus 16. Distributing this negative 5 gives me a sub n equals negative 5n plus 5 minus 16 or plus a negative 16. Combining like terms, I get negative 5n minus 11. Using this rule to find the 19th term, we end up having a sub 19 is equal to negative 5 times 19 minus 11. This ends up equaling to negative 106. Moving on to number 15, d, negative 9, a sub 1, 101. Plug this into the formula. A sub n equals negative 9 times the quantity of n minus 1 plus 101. So a sub n equals, as we distribute, negative 9n plus 9 plus 101. Combine like terms, a sub n equals negative 9 plus 110. To use this now, we're going to have a sub 19 equals negative 9 times 19 plus 110. So a sub 19 equals negative 61. Number 16, word problem, whoop whoop. You visit the Grand Canyon and drop a penny off the edge of the cliff. The distance the penny falls is 16 feet for the first second, 48 feet for the next, and 80 feet for the third second, and so on and so forth. So this is a sequence where it goes 16 for the first second, 48 for the second, and 80 for the third, and it would just continue so and forth, as it says, and so on. So writing a formula to represent the sequence, well, now that we listed it as a sequence, it's a little bit easier, where the d common difference is 32. The a sub 1 is 16 seconds for that first second, or 16, feet for the first second. So plugging this into the formula, a sub n is equal to 32 times the quantity of n minus 1 plus 16. Distributing the 32, I get 32n minus 32 plus 16. And so I get a sub n equals 32n minus 16. Part B, how far will the penny travel after 6 seconds? So we want to find a sub 6. So a sub 6 equals 32 times 6 minus 16. 32 times 6 happens to be 192. And if we subtract 16 from 192, we find that after 6 seconds, the penny falls 176 feet, making sure to include our label of feet. Number 17, similar idea, we're using another word problem. This time, the total bank loan for Sarah's new car is $15,000 or $15,265. The bank automatically withdraws $295.8 every month to pay off the car. Write a formula to represent the sequence. So here, our first term is actually going to not be $15,265, but rather $14,969.2 or 0.20. And the reason why that is the case is because the new car before she makes any payment, it would be a sub 0 before anything happens. Whereas after one payment, A sub 1, we end up having this amount, and the payment would be of 295.8. So I found that by taking this amount and subtracting the first month's payment to give her, to represent how much is left on the car payment, the car loan. So the common difference, though, like we noted, is the 295.8 or 80 that Sarah has to pay each month from her bank account. So now making our sequence, we have A sub n, or our rule for the sequence, A sub n equals 295.8. Sorry, I should do a negative 295.8 because we're taking money out of her account. She's not gaining money. That'd be kind of crazy. And then plus 14,962.20 or 0.2, either one is fine. Distributing here gives me A sub n equals negative 295.8 plus 295.8. Oh, I forgot the n on the first of these two. Plus 14,962.2. So now as I combine like terms, I end up having A sub n to equal negative 295.8d plus 15,265. Hey, wait a second. That's the amount the car started at. Why? Yes, it is. Now, what will the balance of the loan be after 2 years? Well, remember, we're saying each month, so 2 years would be finding A sub 24. How many months are in 2 years? 24. So we have negative 295.8 times 24 months plus the starting amount of the loan, 15,265. So now as we evaluate this and do the math, we end up getting negative $7,999.2 plus 15,265. And so this is how much has been paid in the first 2 years. And now by subtracting that from the total amount of the loan originally, we're going to figure out how much is on the loan left. And so this number is going to be $8,165.8 or $0.80. Now we're going to go on to geometric sequences. Geometric sequences will be defined as, let me change my color here, a sequence of numbers in which the ratio, which we will define as R, remains constant between terms, between consecutive terms. This common ratio I'm referring to is found by dividing any term by the previous term. So here on 1 through 6, we're supposed to determine, is this a geometric sequence, and if so, what is the ratio? So if we divide 10 by 2, we get 5. So we multiplied by 5 to get here. Multiplied by 5 to get to 50. Multiplied by 5 to get to 250. So on and so forth. And once again, if you take 250 divided by the previous term, 50 divided by the previous term, 10 divided by the previous term, all end up being 5. So yes, this is a geometric sequence, and the ratio is 5. Number 2 here. If I divide any term by the previous term, 45 divided by 135, 15 divided by 45, and 5 divided by 15, all end up resulting in us dividing by 3. So this would be the same thing as multiplying by 1/3. And so yes, this is, and it is, a ratio of 1/3. If you had taken 45 divided by 135, you'd end up getting 1/3. 6. Any term divided by the previous term, 18 divided by 6 is 3, 24 divided by 18 is not 3, and 30 divided by 24 is also not 3. This is adding by 6, not multiplying or dividing by the same amount. So no, this is not a geometric sequence. It's actually arithmetic one. Number 7, negative 14 divided by 7 is negative 2. 28 divided by negative 14 is negative 2. And negative 56 divided by 28 is also negative 2. So yes, this is a geometric sequence, and the ratio is negative 2. Number 5 here, if I take negative 40 divided by 80, I get negative 2. Or sorry, I get negative 1/2, I should say. Different number. If I take 20 divided by negative 40, I get negative 1/2. And if I take negative 10 divided by 20, I get negative 1/2. So yes, this is a geometric function, and the ratio is negative 1/2. On number 6 here, negative 36 divided by 9 is positive 4. Negative 144 divided by 36 is positive 4. And negative 56 divided by negative 144 is also positive 4. And so yes, this is a geometric sequence, with the ratio being positive 4. So now we're going to continue a sequence that's already started. So we're told it's a geometric sequence. We need to find the ratio by dividing any term by the previous term, and then continuing that ratio on the next few numbers by multiplying by that number. So negative 21 divided by 7, it gives us a ratio of negative 3. And so we're going to multiply each number by negative 3 to find the next term. So 63 divided by negative 3 is negative 189. Multiply that by negative 3 and I get 569. Multiply that by negative 3 and I get negative 1,701. On number 8, if I take 768 divided by 3,072, or if I take 192 divided by 768, regardless, I end up finding the ratio to be 1/4. And so if I multiply the next one by 1/4, 192 by 1/4, I get 48. Dividing that by 1/4, I get 12. And dividing that by 1/4, I get 3. The next one, the ratio between any number and the previous term is the ratio is 1/2. It's like you're multiplying every term by 1/2 to find the next one. So if I multiply 2 by 1/2, I get 1. And I get 0.5 or 1/2. And I get 0.25 or 1/4. I often will write this as 1/2 or 1/4. Then on number 10 here, any term divided by the previous term is positive 5. So even though these numbers are all negative, the ratio is still a positive 5. And so if I multiply negative 125 by 5, I get negative 625. And if I continue that trend, I get negative 3,125 and negative 15,625. So these numbers get pretty big pretty quick, or in this case really small really quickly since they're all negative. So now, just like there was a formula to find the arithmetic sequence, the nth term of the arithmetic sequence, there's similarly a formula for the geometric sequence for the nth term. And it's this formula, where it's a sub n is equal to a sub 1 times r to the power of n minus 1, where a sub 1 is the first term again, and r is the ratio like we were talking about earlier. And n is whatever number of term you're on or wanting to find. So write the rule for the nth term and then find a sub 7, aka the 7th term. So here the first term is 3, the ratio is 3, and so we have a sub n equals 3 times 3 to the power of n minus 1. A lot of times I'll put this r in parentheses, and that's our formula, our rule. And so to actually use this to find the 7th term, it's a sub 7 equals 3 times 3 to the power of 7 minus 1. Now the power of 7 minus 1 is really the power of 6. And then that ends up giving us, if we take 3 to the power of 6 and then multiply that result by 3, we end up getting a to the power of 7 to equal 2,187. Now, just like before, if you don't want to write this middle step, that's perfectly fine as well. You can jump straight from the orange to the red if you would like. Number 12 here, our first term is -4. Our common ratio is -5. So a sub n is equal to -4 times the ratio, which I'm going to put in parentheses here, especially since it's negative to the power of n minus 1. So now to use the rule to find the seventh term, a sub 7 is equal to -4 times the quantity of -5 to the power of 7 minus 1, which results in a sub 7 equaling -62,500. We will now move on to number 13. So here, the a sub 1 would be 400, and our R ratio would be 1/2, because we divide by 2 or multiply 1/2 to get from one to the next term. And so here we would have our a sub n equal 400 times 1/2 to the power of n minus 1. And when we have a fraction, we do want to put that ratio in a parenthesis there when we're raising it to an exponent to emphasize that it's an entire fraction that's being raised to the power, not just the numerator. So that would be your rule. And then to find the seventh term, you'd say, well, a sub 7 equals 400 times 1/2 to the power of 7 minus 1, which is secretly the power of 6. And so a sub 7 would end up equaling 6.25. Number 14 here, we have our a sub 1 is 1, and our R ratio is 5 that we're multiplying by each time. And so a sub n is equal to 1 times 5 to the power of n minus 1. So this 1 really becomes unnecessary, and I don't necessarily need parentheses here as long as I put a multiplication dot as well in the middle. Either one's fine. So, or since the 1's unnecessary, I could just put 5 to the power of n minus 1 as well. So then now to find the seventh term, a sub 7, the seventh term in the arithmetic sequence, is 5 to the power of 7 minus 1, because once again, I don't need to say that I'm multiplying by 1. And this tells me that the seventh term then is 5 to the 6th power, which is 15,625. Moving on to number 15 here, my a sub 1 is -1, and my ratio is +4. Even though these numbers are negative, the ratio is still that it's multiplying by 4. And so then my a sub n is -1 times 4 to the power of n minus 1. Now here we do need to write this 1 because there is a negative, or if we leave off the negative, we just need to make sure that there's a parentheses here stating that we apply the exponent first and then make it negative afterwards. So that's our rule. And then to find the seventh term, a sub 7 is -1 times 4 to the power of 7 minus 1. So you take 4 to the 6th power, make it negative by multiplying by -1, and we get -4,096 as our answer. Moving on to 16, a sub 1 here is 729, and the R ratio is -1/3 that we're multiplying by each time. And so then the a sub n, it zoomed out and zoomed back in on me. That was kind of interesting. Oh, and now it's not wanting to actually write down the terms I have. I'm writing and it's just erasing on me. So it'll probably pop up in just a moment, unfortunately, but it is what it is. So maybe it'll actually let me write here in a moment, but we'll see. I'm not getting too high of hopes at this point. Maybe I use a pencil? Nope. Nothing wants to stick around. Oh, it's moving it over there, though. That's an interesting change. I've never seen this before. So I apologize for these technical difficulties. If I had some control, I would fix it. Here we go. A sub n is equal to a sub 1, 729, times the -1/3 to the power of n minus 1. So as we take that rule and then we plug in 7 for n, a sub 7 equals 729 times negative 1/3 to the power of 7 minus 1, which tells us that the seventh term in this geometric sequence, sorry, not arithmetic, I called it arithmetic on the last problem, I think, is just 1. Then 17, our a sub 1 is 6, our ratio is negative 2, and so we plug this in, a sub n is equal to 6 times the quantity of negative 2 to the power of n minus 1. And technically you don't need this parentheses as well, the multiplication dot would do. And then the seventh term, a sub 7, is 6 times negative 2 to the power of 7 minus 1, which results in the seventh term being 384 in this geometric sequence. Number 18 here, if we take 12 divided by 8 or 18 divided by 12, we end up finding that the ratio here is 3/2 or 1.5, but the first term here is 8. And so we have a sub n is equal to 8 times the quantity of 3/2, 3/2, to the power of n minus 1 for our rule. And then making it that n is 7 to find the seventh term. And then completing the math, we end up getting the seventh term to be 91.125. Now we're going to apply this with one problem. So the table on the left shows a car's value for 3 years after it's purchased. So 1 year after it's purchased, it's $10,000. Second year after it's purchased, $8,000. Third year after the purchase, $6,400. So write a rule to represent the car's depreciation. So if we take the 8,000 divided by 10,000 or 6,400 divided by 8,000, either way, we find the ratio to be 4/5. And a sub 1, we can see that after 1 year, it's a value of 10,000. So we put this into our rule, a sub n equals 10,000 times 4/5 to the power of n minus 1. And now we're going to figure out the value of the car after 10 years. So a sub 10 is equal to 10,000 times 4/5 to the power of 10 minus 1. And this all ends up equaling that after 10 years, the car should be valued at $1,342.18. Now, that's not the case with every vehicle, to be clear, so don't just go worry like, I'm losing all my value in cars. Some cars retain value better than others, but it is subject to car, and they do all lose value. Well, that wraps up section 5 of chapter 4 for Algebra 1, which wraps up Unit 4 for Algebra 1.